introduce variables with you guys and how it works with polynomials.
All right, who's excited? Woo!
Hey.
All right. Excited? Not excited. It's math class, not excited. It's time to get excited. Okay, so let's try the problem here. Okay, these are the type of problems you're going to have to factor. Okay, now we're going to start getting into the factoring part using the GCF. Okay, somebody tell me the GCF between these two numbers. 6. Very good. Okay, so GCF is 6. Okay, this is where the factoring part comes in. We're going to divide each number by the GCF. Okay? Does everybody understand that? Okay? So what we do, we're going to pull it out. Okay? We take the 6 out. Okay? Put in parentheses. Okay? What's 6 divided by 6? 1. Okay, so we use next. What's 12 divided by 6? 2. Okay, that is written in factored form. Not that bad, right? Okay. From here? Yes. Okay. So where does the 6 come from? Okay. What was the GCF of 6x and 12? Does someone say? 6. Okay. So they both have a factor of 6. Okay. So then what we do is divide each term by the GCF. And we bring it out, okay, and then we have whatever remaining. Any questions? Okay. A little tip, give it to you. Okay. You want this inside of parentheses to be in the lowest, simplest form it can be. Okay. We cannot take another number out except 1 from this. Okay, to make it look smaller or anything like that. Okay. And also, this number is the same as this. Okay? Everybody understand? Any questions? Yes, sir.
What happens if like the x is 1 and the 2x?
Well, like if this was a 12?
Yeah.
Yes. But this would be a 12 and this would be a 12. Okay? So you pull out a 12 and this still would be 1. And this would be 1.
So not always be 1.
No. Not always. And we're going to do examples. Where's the eraser? Okay, next example. So what's the first step? Someone say it.
Find the greatest common factor.
Yeah.
Okay, now raise your hand. What is the greatest common factor? 1. Very good. Okay, so go with the process. We're going to divide each number by 1, right? And what do we get? 7y plus 9. So it's the same thing. So this is written in factor form. Understood? Okay. Yes, sir.
Would you put the 1 outside, like, would you do the kind of?
No, we don't need to do that. If you would like, I guess it wouldn't matter, but just keep it easy, you don't need to do that. Okay? All right, let's go a little tougher. All right, what's the first step? Forgot.
Find the greatest common factor.
Find the greatest common factor, that's right. Okay. So, what is the greatest common factor? Does anybody know? Put that back in the gray shirt. 3. Okay. 3. Okay. Not bad. How about anybody else? 4. Not 4. Is 4 going to 3?
Oh, no, my bad, my bad.
Right, okay. So, okay, we're getting a start, okay? We got 3. Okay, so they both have 3 in common. So anything else in this equation that seems maybe in common? Why? Okay? We can start doing this with variables. Okay? So they both have a y. So this is our greatest common factor. Okay? So then what do we do with the greatest common factor? Divide. Okay? So it's 3xy divided by 3y. Anybody?
X.
X. How about 12y divided by 3y? 4y. Good. What's the question? Any questions?
Nope.
Okay? Awesome. All right, last example. This one's a big one. Okay. So who's going to tell me the GCF? Okay. 14's it? Okay. That's a start. Okay. Okay. So that eliminates the numbers, okay? Are there any variables in common?
No.
There's none.
Actually,
Yes, ma'am.
So when you're finding the greatest common factor, do the variables have the same color?
Oh, okay. Darren?
You could, well, they both have an X and a Y in common.
Okay. That's awesome. Okay. So they both have an X. Okay. How many does this have?
One.
How much does this have?
Two.
So it's like 2 boys, 1 boy. Okay. So what's the most we could pull out?
One.
1. Okay. How about the Y? How many? How many?
Three.
Okay. 2 girls, 3 girls. What's the most we could pull out?
Five.
2.
Not 5. Okay. Now, what do we do with the greatest common factor?
Divide.
Okay. What do we get? Sure.
3xy.
Oh, over here. Okay. Okay. This is, let's see, division of exponents, right? Okay. So what about this one?
This,
Why would it be nothing?
wait, no, 1.
1.
Oh.
Any questions? Yes, sir.
Okay, so, I don't understand how you find out the greatest common factor of that one. I'm confused on that. So I get 14, but then I don't really get how you get like x equals y squared. On the other side, x squared, y cubed.
Okay. So you understand that 14 is the greatest common factor, right? Okay. How many x's does this have?
1,
Okay. How many does this have?
2.
Okay. You 2 come here. Okay. Another little activity that Mr. Oven did. Okay. How many can we take out? 1. C, and C. And it leaves 1, correct? Same thing we're doing here, okay? 1, 2. The most you can take out is 1, because you can't take 2 away from 1, okay? Is that helping a little bit? You're still a little confused.
With the, what about, no, I can.
You sure?
Yeah.
With the Y, okay? Can I have you 2 ladies come up here? And then 3 ladies right here. Come up here. 3 ladies come over here. Okay? We have 2Y over here, 3Y over here, okay? What is the most we can take out? Y1. All right, push it down, push it down. Is there anything else in common with this? Anything in common with this group? By gender. Okay. How many do we have over here? How many do we have over here? Can she sit down? Can she sit? Someone else to sit down over here? They're both in common, right? Let's see. One left. 2, 3. We took out 2 pairs, 2 groups. Okay? All right, I'm gonna have you guys work on some stuff on your own. For a second.
Huh?
Any questions before I move on?
So you're basically just subtracting it, right? And so like at the end, if you multiply it all, you should get the same answer.
Yes, okay, but we're not subtracting.
Oh,
Okay?
yeah, yeah.
We're
that-
dividing. Okay? Yes, at the end, you should be able to multiply it back all the way through and get the same answer, which is a good way to check your answer. Okay? Oh, if you haven't been taking notes, I would suggest taking them now. Will everybody be able to see if I'm right over here? No? Yes? Yes? Okay.